This is the Unit 1 Reading Graphs intro lecture. So we're going to start with a couple examples. We're going to start with the happy camel. He's going to start at a position of 1 meters. So down here we have time. So if you're starting somewhere, you're looking at the time where time is 0. And the position is 1 meter. Now this is also called the y-intercept. So the y-intercept is also your starting position. And then at 7 seconds, it's at a position of 5 meters. So 7 seconds, we're going to go up to 5 meters. We're going to draw a dot and connect these with a line. So that's the line that represents my happy camel's motion. And then it says, how far did the camel move between 0 and 7 seconds? So if we want to look at how far it went, we'll notice it starts at a position of 1 and ends at a position of 5. So how far it went is also called its displacement, which is written delta x, and that's going to be the difference between 1 and 5. So I'm going to think of it as 5 final minus 1, which is my initial. So that's 4 meters. So when we're thinking about how far something goes, we're looking at the change in height on a position versus time graph. And then it says calculate the slope. Okay, well, slope is rise over run. And the rise we talked about is this 4. It's not 5, it's 4 because it starts at 1 and goes to 5. So my rise is 4 and my run is between 0 seconds and 7 seconds, which is a run of 7. And then it says, what are the units? Well, when we're doing units for a slope, we do it the same way as we do it with numbers. So the rise is 4, but specifically it's 4 meters. So I'm looking at the units here on my y-axis, and then the units for my run are going to be these seconds. So that's the units for my run because that's 7 seconds. And so if you pay attention to the numbers, oh, it went up by 4 meters and it went over by 7 seconds, that's going to help you with the units. And lastly, I want to think about it. Okay, what is meters per second? Well, when we're talking about miles per hour, that's a distance per amount of time. And the speed of the camel or the velocity of the camel is going to be the slope of our position versus time graph. All right, so to summarize so far, on a position versus time graph, our y-intercept is our starting position. Our slope is our velocity, and how far we went is how much the graph went up. So displacement is the change in height. The slope is my velocity, and the y-intercept here is my starting position. So remembering those things, now we're going to do another example. We have 2 bicyclists that are racing according to this graph. And the first thing is, do they start at the same point? Well, I need to remember that my y-intercept is where they start, and they have 2 different y-intercepts. Therefore, they must start at 2 different places. And B then would start at a bigger starting position than A, and A is going to start at a position of 0. To know which one of these is farther ahead at 7 seconds, I'm going to first think about, okay, well, if that's 5 seconds, 7 seconds is about here. And so the one that's farther ahead is going to be the one with a bigger position. Well, that means that the one that's higher up is going to have a bigger number. Because if I were to put numbers on this, A's number is going to be bigger than B because it's higher up at 7 seconds. And which cyclist is traveling faster at 3 seconds? Well, at 3 seconds, remember that we're still thinking, okay, the speed that it's going is the slope of the line. Well, at 3 seconds, which is about here, the slope of A is steeper than the slope of B. That means that A is going to be going faster because the slope is steeper. And that leads into the question, are their velocities ever equal? No. No, they're not, because the slopes are never the same. In order for them to have the same speed, I would need two lines that were parallel to one another. This would look like they were going the same speed if they had the same exact slope. And what is happening at the intersection? Well, these two bicyclists, don't think of them as actually crossing paths. Think of it as two lanes on the freeway or two lanes on a track. People don't run into each other when they pass each other. So at 5 seconds, they have the same position at the same time, but that does not mean that they have to get into a car accident or a bike accident at that moment when they're at the same position at the same time. It just means they're the same distance from 0. All right. If you have any questions about these two, let me know.